This will be part 1 of what will be an ongoing series for ChatGPT Code Interpreter, and all parts will be for those who don't know any coding. In this video, we are going to be using ChatGPT Code Interpreter in the following ways. We're going to find data online that show income by age group over time, and we're going to talk about where to find good data on almost any topic. We're going to find data on the average amount a household pays for healthcare over time, and we are going to hone in on the age group 25 to 34 in the United States. We're going to use ChatGPT Code Interpreter to generate reports with charts comparing what percentage of income that age group has paid for healthcare over time, and look at the trends in graph form. We are then going to switch gears and download NBA playoff data dating back to the 1970s. We're going to generate 10 different charts comparing different player stats over time. We're going to look at how it does generating reports with PDFs, and we're going to do some chart videos. And then at the end, we're going to finish with something fun. There are timestamps for you to move around. And as an intro, for those who are curious about ChatGPT's new feature, I'll do a brief overview of what it does right now. For those who are unfamiliar with ChatGPT, welcome to the internet. ChatGPT Code Interpreter can be given a spreadsheet with almost 1 million rows with many columns of data, and it can create basically any chart imaginable with that data. It can output those charts as PDFs, PNGs, JPEGs, and in some cases, video. If you take 5 minutes to learn some basic video editing, you can turn those PNG images into captivating visual chart videos. I'll show you how in this video. Code Interpreter is better at solving problems than GPT-4. Code Interpreter can write and execute Python code in a persistent workspace. When you hit enter after writing a prompt and giving it data, you will marvel as you watch it work for sometimes 5 minutes, trying something, failing, trying again, failing, trying again, and coming to the correct answer and giving you exactly what you looked for. Users do not have to debug code. AI does all the work, making it usable to anyone that knows English. Code Interpreter can solve complex math problems, and it works more accurately with words than the GPT that came before it. The AI reasons in a way that feels like it is a human doing that reasoning. It just thinks thousands of times faster than we do. When you ask it to write a report on a ton of data, it can prepare a report as if it is being prepared for your boss. Want a specific type of report? Just tell it what your boss wants to see. No matter the profession, no matter the level, there are things you can do with this tool to level up on many dimensions of work and life. For me, most notably, decision-making, efficiency and automation, subscribing to this channel if you want more videos like this, storytelling with visuals and data, and freeing up time. If you would like more of these videos, let me know in the comments, like and subscribe. And with that said, let's dive into the video. So here is the first example. I want to compare different age groups and their income over time. I want to see what people in their 20s can buy now, their purchasing power, versus in the 70s. Compare the people in the 20s age range then. So I looked it up on Google. Here is census.gov, and you can find all different types of data sets. So I found this data set. Age of head of household by median and mean income. And I downloaded this, and we can open it up right here. So this is what we were looking for. We see that this is 15 years and over. We see that this is 15 to 24, right? We see that as 15 to 24. We have the median income in dollars, 51,645, right? And then we have an age range of 25 to 34, age range of 35 to 44, age range of 45 to 54, and so on. So we want to analyze this data on GPT Code Interpreter, so we need to turn it into a CSV. It's downloaded as an Excel spreadsheet, so browse. I have a place where I put all of my useful data sets, and so we are going to put this in useful CI data. And I am going to create a new folder and make this age, and let's save this as average income by age over the years. And then we need to save it. I'm on Windows right now. We save this as CSV. and hit save. So now we have that saved in the correct location. So now it is time to come to GPT-4 Code Interpreter. If you don't have it activated, you need to activate it, and so it should show up right here. If it's not activated, you're going to go to Settings, and you're going to go to Beta Features and make sure that Code Interpreter is turned on. Now that it's set up, we can add that file that we were just uploading. Let's start off with the basics. What does this CSV tell us? And I start with the next line first whenever I work with a new data set. So what does this CSV tell us? What formatting changes do you suggest we do to make data analysis easier? And you can see here that they are fixing the column names, and in the year column it says that it adds like this little 40 here, which it's actually 100% true. If we open this up right here, we can actually see that it does. It adds these little parentheses, and I'm not even quite sure what it means, but they're unnecessary for data analysis, so it's actually going to remove them. And now it is finished responding, and look at how long this response is, and look at how much work it's putting in. I cannot believe this is only 20 bucks a month. The data set now appears to be in a more suitable format for analysis. We have meaningful column names, year column clean, numeric income columns. So the next prompt that I want to use is create a line chart that shows the real dollar amount of money each age group made over time. Make each age group a different color. Make the colors of the line very different from each other. And so we can see here it worked for a lot. I apologize for the confusion, apologize for the confusion, apologize for the confusion. It works through actively. It really tries to understand, it really tries to fix its mistakes, and it does it, and it finally finished working. Okay, so now I want to compare this to healthcare prices, and I just did about 10 minutes of looking for good data, and I found this data, and it says get the data from 1970 until 2021. We see the increases in healthcare prices, and we're going to see how it compares. I downloaded the data, and here it is. So we are going to save this one. Again, save as, browse. So I cleaned up that initial chart. Now let's go ahead and drag in the average healthcare prices over a very similar time range. So this is the average healthcare prices over a similar time frame. Use the real dollars, not adjusted for inflation, and I want you to plot it on the graph above. Create its own vertical axis on the right that is fit to scale for this data. And we are letting it go to work. It basically says it appears the relevant columns are year and total NHE per capita, which is true. That is the data that I want it to look at. Absolutely. Okay, so now it's finished. And remember, this is for ages 25 to 34 years old. Okay, so here is the graph. And I actually think we can make this more useful. I think we should make it as a percentage. Show me, instead of these two lines, the ratio of total NHE per capita divided by the income. So we want to see a ratio, like how much of your income goes to healthcare on average. Now, this is where it gets interesting. So as you can see here, in 1980, it was 0.05, so 5% of healthcare expenditure. So as we can pull it up here, we see that in 1980, it was 1,000, right? 1,000 per year for healthcare. 1,000 per year for healthcare. We can see that it's at 5%. And today, around 2020 at least, it's almost so it's about 17% of your income in this age range will be for healthcare. And say, give me a pie chart for every 5 years showing healthcare versus income. Make this a PDF and have the year labeled. And now we are letting it do some work here. And it did all this work and it gave us a PDF. Let's go ahead and check out the PDF. Here we have it in all these different years. So we see 1970, 80, but watch this, check this out. So what we are going to do is I want this to be in more aesthetic colors and I want them in PNGs so we can make a little video. That's what we're going to ask it. So for each of these, first, can you pick more contrasting colors and a slightly bigger font? Second, can you print these as, or can you export these as numbered PNG files rather than on a PDF? This will allow us to make an animation. And there you go, it gives us all of these files. Okay, so now that we have them downloaded, we can bring them in. So I'm going to select them in the right order that we want them to come in. So the first one should be 11. Yep, 11, 10, all the way through. So we have in 1970, 1975, and so we have it all the way through. So they are nicely lined up in the timeline. What we're gonna do is we're gonna select all of it, and then we are going to nest them. And it doesn't matter what you put for the nest name because we are creating this. What we're gonna do is we are going to press R, which is basically, it turned that into a video where each frame is equally, I think each frame or each photo would be there for 5 seconds. We don't want it that long. R makes that whole sequence drag down to whatever you want, but it'll still be evenly distributed. So we can drag it to, say, 4 seconds, right? And then what I want to do to create the animation, we're going to put an out point at the end, sequence render into out. And once it's done, we can move this right here and let's check it out. But that's too short. We're gonna want to go like this. We're gonna wanna make it, let's make it 10 seconds long. And now we can go sequence, render into out. And this is what it'll look like. We can see 1980, 1985, 1990, 1995, 2000, 2005, 2010, 2015, 2020. Pretty cool. And then you can just export it and we'll go in default settings and export and then open up the file and we have it. We can play it and it's just a normal video. We can put this in a website. We can put it in a tweet. Now at the end here, write a report on the relationship between the age group income 25 to 34 and health care prices. And here we go. It's literally writing a report on the relationship between income, age group 24-35, and healthcare prices. Findings. And it literally is writing out the findings. And here we go. We can create an entire report just like that in literally no time. Okay, so now let's move to another example. And let's move to one with a lot more data. So now we're going to look at a data set that I found on Kaggle. Kaggle.com is not a sponsor. It is a place where I've found so much data. So I want to dive in and look at some sports statistics. And I'm downloading 1950 to 2002 NBA playoff statistics. And we are going to dive in here and we're going to make sure this is saved properly. Let's do an analysis of all of them. So we're going to open up a new chat. We're going to hit GPT-4 Code Interpreter. Now let's go ahead, open it up, and we are going to insert it. Now that it's inserted, let's go ahead and tell me about the data I just gave you to give me an introduction about some surface level trends that you notice. Just, a little introduction. Okay, so each row is a player for every season. So each row represents a player's performance in a season. So if you play every year, you're going to be in every single year on this, so you're going to be here in 1950, and then you could also show up in 1951, for example. Now let's dive into the analysis. Give me a very detailed PDF report comparing the statistics of Michael Jordan, LeBron James, and Kobe Bryant. I want you to use statistics and arguments commonly found important to when arguing who is the best basketball player. Use many charts. Enter. All right, so it is saying that these are the most important statistics, and I will also include the championship. Okay, so it's finishing work. I've filtered the data, Michael Jordan, LeBron James, Kobe Bryant. So it's filtered the data, and it is going through and grabbing all of these championships won. Okay, this is pretty cool. This is pretty cool. Okay, so it just announced these things. Now it is preparing the visualizations. Oh my God, that is crazy. So I copied this over to this chart so we can take a closer look. We have Michael Jordan, Kobe Bryant in the middle, and LeBron James. We see that the points per game, obviously, so Kobe had this like on-ramp where he wasn't a super important player. And we see that the rebounds per game, again, we can see Kobe's, we see LeBron is much higher, but we can actually adjust this data. We can adjust this data, and we can come back here and say, can you recreate the graphics and PDF and use colors that are more contrasting? Make sure that, or make the lines a little bit thicker on the line charts. Oh my God, this is absolutely nutso beans, dude. And I don't even know if anyone says nutso beans, but take a look at this. And you can just copy this, or we can save this image, right? We can copy it and take it over to any document here. And look at how clean this image is. Like, look at this, points per game, rebounds per game, and it shows you through the seasons. And so you see the light overlap through the seasons. This is crazy, 3-point percentage. I'm not sure what's going on here, but this is just crazy. Is there free throw data? Where's free throw data? Yeah, so free throw percentage, we see that Michael was just very, very consistent. Kobe was higher than LeBron, just really started dropping off later in his career. And yeah, it was really close to that 60% mark. Field goal percentage, LeBron just always had that slight edge, he's just closer to the rim. Rebounds, he dominated. Assists per game. I thought LeBron had a higher edge on LeBron, but I guess not. Win shares, value over replacement. And obviously championships over championships 5, 4, 5, and 6. Wow, this is absolutely amazing. Okay, now I want you to get really creative. I want to know more about the best 50 players in the NBA every single year in the playoffs. Actually, let's go the best 25 players every single year in the playoffs. Show me multi-year analyses on a PDF and use many creative charts. I like charts where players are labeled. Use colors on charts that contrast. He's like, okay, I see this is a multi-year analysis. This could be an expensive analysis. So we need to define how we're selecting top players. And for the sake of simplicity and relevance, let's choose player efficiency rating as the measure of per minute productivity and takes into account accomplishments such as field goals, free throws, three-pointers, assists, rebounds, blocks, steals, and negative results such as missed shots, turnovers, and fouls. Next, we will create a chart each year showing the top 25 on player efficiency rating. Given the number of years players, this will result in a substantial number of charts. We use a color palette that ensures, wow, this is gonna be amazing. I hope this works. Uh-oh, some red. Okay, so here is a PDF file. Let's take a look at it. Wow, oh my God. A 71-page report on the top player efficiency rating. Okay, but player efficiency rating is flawed. And because obviously player efficiency rating, someone might go into the game for just a few minutes and be really efficient, but it's harder to do that throughout if you're playing a lot of minutes. We'll create this for let's just do this. Recreate the same report, but with points per game. On the chart, label each bar with the following stats for that year in this format. So let's go like this. So on each bar, I want to see this little bracket, and let's go points, or no, it'll show us points. So it's like recreate the same graphs with points per game as the bars. And then we want to see rebound, and then and then we will say what we can actually give variables. So let's just go Actually, we don't even need, we can go rebounds, assists, field goal, percentage. Let's try it. Okay, that took a little bit, and it says, here's a PDF file containing your chart for each year. Please note that due to a large number of charts, one for each year, the file might take a while to load. So we are opening it up. Nope, didn't take that long. Wow, and it has a little HUD, so we could see that it has rebounds, assists, field goal shooting percentage. Okay, so this is useful. I guess you could turn this into an animation. It wouldn't be that hard. It would actually be relatively easy, but I actually don't want to do that. I want to create a cooler chart that's actually more useful, more at a glance, and we can actually look at overall trends. Career, show me Tim Duncan's career stats over the course of his career. Create a detailed report on his stats and tell me how he changed over the years. And there we go. It gave us this report here showing Tim Duncan's full career. And I pasted it here in this Google sheet so we could see it a little bit better. But we can see his points per game trended down towards the end of his career. His field goal percentage, always between 45% and around 58%, a very high percentage shooter. And now what we can do for the final thing that I will do is recreate these, but compare them to the league average for that given year. Okay, this one actually went very, very quickly, but we can see here that the league average obviously isn't great. And it's best to look at the percentage-based ones, but we can see here that the average field goal percentage is, hovering a little over 40%, and then he is up often above 50%. So that is very interesting, and it's very cool that it actually spread it out throughout the entire career. Here we have free throw percentage, so some above, some below, mostly below the average. But player efficiency rating is a better one to look at. Obviously, this one is just very impressive how efficient of a player he was. Okay, now let's add 2 more players. Keep these exactly the same, but add LeBron James, Kevin Durant, and Kobe Bryant, and also make each chart larger by giving a new line in between charts. Output should be in PDF form. And here we go, our final analysis for this NBA section here. Player versus league averages. We see that Kevin Durant pulls away here towards the end, but these 3 are relatively close. We can see that in terms of assists per game, and again, these aren't contrasting, so always remember, recreate these with contrasting colors so I can tell them apart. Keep everything else the same. And as you can see, it is much easier now to analyze the players. So we have points per game. We can see that Kevin Durant, while he played, was really going after LeBron, and towards the end of his career kind of took that one over. LeBron James had a very solid player efficiency rating, but didn't come close to Tim Duncan. Here we can see that the assists per game dominated by LeBron. That's no surprise. Tim Duncan obviously dominated blocks for a lot of his career. Kevin Durant, sneaky with the amount of blocks he has. Steals per game. LeBron James clearly did pretty well. Kobe Bryant was pretty consistent his whole career. Tim Duncan, very low. That's not uncommon for a big. Anyway, this was a long one. We learned a lot of different things. Subscribe if this gave you value. I'll be putting a bunch of links in the description. Check those, and thank you for watching.